When a transaction is executed, the information is recorded into a new block and sent to all nodes in the network. A group of nodes then act as verifiers, who form consensus on whether the transaction was legitimate and should be added to the blockchain. They receive rewards for their efforts and incentivize participation. This is referred to as consensus in a decentralized environment where verifiers must be chosen at random to prevent manipulation. We propose using sampling problems as a method to define consensus on blockchains. A classical example is the Galton board, where balls run through a pinboard and land in buckets. In this case, the probability distribution of the buckets is a binomial distribution. But the probability distribution of the Galton board is very easy to spoof and doesn't require performing the task at all. Instead, we suggest a hard quantum sampling problem, also known as boson sampling, where the distribution of outputs is random and difficult to spoof on a classical system. It would take available quantum hardware to solve the problem efficiently and calculate distribution. In a boson sampling apparatus, several single photons pass through an interferometer, and the output is measured using detectors. In the video, 3 single photons shown are measured on the other side of the interferometer. Statistical calculations are conducted to measure probabilities and build consensus. As the data is added to the demultiplexer, the problem is re-randomized for every new transaction by permuting the locations of the input photons based on the previous block information. Once nodes have obtained the necessary samples, statistical measures are compared between nodes. We rely on coarse-grain statistics, where the sample space is divided into bins, whose probability distributions converge. To prevent spoofing, the way in which samples are allocated to bins is not determined until after all nodes have committed their samples. Nodes participating honestly, by contributing legitimate quantum samples, will observe statistical consistency with one another, winning the right to participate in consensus and seek their reward, while dishonest ones will lose their stake. Once a consensus is reached on a particular transaction, the new block is successfully added to the blockchain.